Hello, Bio 16. We are going to be covering Chapter 21, the cardiovascular system, focusing on the heart. We will be doing a separate lecture for more blood vessels next time. So the cardiovascular system is really important for helping maintain fluid levels, interstitial fluid, and remember that's the fluid between the cells out in tissues. In addition to that, the cardiovascular system helps maintain CO2 and oxygen levels, waste levels, and nutrient levels. So basically what's happening is you have a bunch of chemicals floating around in your interstitial fluid among your cells, and those chemicals need to be exchanged between cells and the fluid. So blood is always constantly moving around to affect the homeostasis of cellular tissues. So blood movement itself depends on how well your heart functions. So heart function has to do with strength of your heart, but also how well your respiratory system works as well. That's a separate lecture. For now, let's just focus on the heart. So our hearts beat about 100,000 times a day. Can you believe that? It moves anywhere from 5 to 30 liters per minute, depending on how fast your heart is beating. And we run all of that through about 60,000 miles of blood vessels. Now, that is different depending on how large your body is. You know, I might not have 60,000 miles of blood vessels, but somebody else, you know, an average sized person would. And so how is all of this regulated? How is our heart rate regulated? Remember the medulla oblongata from the last unit? The medulla has sensors and centers in the brain that talk to the heart, and we'll talk about that in a little bit. But what the medulla does is it ensures that there's a constant heart rate going to ensure that there are adequate nutrients, fluids, and chemical levels moving throughout your body so that cells and tissues are nourished and waste products are being removed. So let's start with the heart itself. Where is it located? It's located anterior to the chest wall, okay, directly posterior to the sternum. So remember the sternum, that bone down the center, the midline of the body. And the heart lives inside of the pericardial cavity. Now, we talked about cavities very early on in the semester. What the pericardial cavity is basically a space, an airspace that has tissues around it. And it's kind of like if you punched in a balloon. And so the pericardial cavity ensures that the heart is separated from tissues surrounding it, like the lungs or the musculature of the diaphragm. So the diaphragm would be down here, inferior to the heart. This is where we actually do use inferior. And there's a fibrous connective tissue area here, adjacent to the heart and connecting the pericardial cavity to the diaphragm. So this is a larger version of what we were just looking at, and now we've included a horizontal section through the body. So here is where the slice is taken, going right through the blood vessels. And so what you'll see here is the right ventricle and the right atrium. We'll get to all this in a little bit. Here's the left lung and the right lung. One of the things I want you to focus on here are the cavities. So here's the pericardial cavity. And then over here, we have another cavity right there. I'm sorry, I am not very good at using my pen yet still. These cavities are surrounding the lungs. These are the pleural cavities. And so basically what you have is a pleural cavity right here and the pericardial cavity right here. And each of those cavities has fluid in there. And the fluid reduces the amount of friction that occurs as the heart is contracting and the lungs are inflating and deflating. So here's the heart, here are the lungs. Again, we've talked about friction in tissues, and in these very delicate tissues that are moving frequently, you do not want a lot of friction because that's going to cause a buildup of connective tissue or scar tissue. Here's another version here showing you the edge of the pericardial cavity. And so what happens is that these pericardial linings and the pericardial and the pleural linings reduce friction, keeping the tissues nice and cool and from developing basically scar tissue or calluses. You could think of it as calluses. So the pericardial membrane is what we call a serous membrane. A serous membrane is made up of two layers. The visceral pericardium, and visceral means like deep in the body. It can also be called the epicardium. And it's a series of loose connective tissues bound to the cardiac muscle. So loose connective tissues. Boy, one of these days, hopefully I'll get better with this pen tool. The pericardium is lining the pericardial cavity. And so this also has a fibrous component and has lots of irregular connective tissue, lots of collagen, lots and lots of fibers connecting the visceral pericardium. So here's our parietal pericardium, or fibrous attachment here. And we can also call that the pericardial sac. So now let's talk a little bit about the heart itself. Those are just the sacs surrounding the heart. The heart is made up of cardiac muscle. The heart itself can be organized into 3 different layers. First, we have the epicardium, which is, again, the visceral pericardium. So visceral meaning deep. And this is a very thin layer. It's transparent. It's thin. Here's the epicardium right here. And I'm sorry if I said that was all cardiac muscle. This is not. This is connective tissue. We have the myocardium, which is actually the cardiac muscle. So excuse me if I was misleading there with the epicardium. So here's the myocardium right here in the middle part. And those are all those branched individual muscle cells with single nuclei. And yes, here they are, the gap junctions. And then we have an endocardium, okay, or an endothelium. The endocardium is on the outside here. Well, it's not really on the outside. It's like on the deep inside. So here's the endothelium. Okay, sorry. So here is this simple squamous epithelial layer that's basically lining the inside of the heart. It also lines the inside of blood vessels. So get used to looking at this organization of squamous epithelium. You're going to see this a lot in the cardiovascular system. So you have the endocardium, the inside of the heart, right here. The myocardium, so this would be number 1, or layer number 1, number 2, and number 3 out here, going deep to superficial, okay, for the heart wall. The 4 chambers of the heart, which I'm assuming most people are familiar with, will be the 2 atria, the right and the left. So here is the right, all right, and here is the left. And each atria is a site where blood comes into the heart. The right atrium is going to bring deoxygenated blood into the heart from the superior and inferior vena cavas. Okay, so here's the inferior coming in right here. Here's the superior coming in. So superior would be circulation from the head. Inferior would be circulation down below the heart. And then up here with the atrium, the left atrium. The left atrium is interesting because this is bringing blood in from the pulmonary circuitry. In other words, from the lungs, okay? Uh-oh, she's going to try writing a word again. I'm just going to say lung. So those are the atria. Here, the right is deoxygenated, the left is deoxygenated blood, and the left is going to be containing oxygenated blood. Now, in terms of the ventricles, there again is the right and the left. The right is going to contain deoxygenated blood that's going to go out to the lungs. And then over here in the left ventricle is going to send blood out through the aortic arch to the body. And so it's going to go to either superior circulation up to the head through or the upper part of the body, the shoulders, the neck, through the carotid, through the subclavian artery, the brachiocephalic trunk, and basically, or it's going to circulate down to inferior circulation. So what's happening is the blood pumps is blood comes in through the right atrium, goes through the right ventricle, out to the lungs. Okay, then blood comes back in through the left atrium from the lungs. It's oxygenated. It loops through the the left ventricle, out the aortic arch, and out to the body. It's going to be very important for you to study the pathway of blood flow. I will find a video to post for you guys on the Unit 4 module. So the atria are separated by a septum. Whenever you see the word septum, that means it's a wall separating 2 areas. So the intraatrial septum separates the right and the left atria. The fossa ovalis, which I'll show you on the model, on our model video, is a really small depression. Let me see if you can see it back here. Yep, here it is, the fossa ovalis. And this is kind of a really cool spot in the heart. It's what's left over from the foramen ovule, the fetal foramen ovule. And this is basically a hole between the right and the left atria that occurs in fetal, in the heart during fetal development. It closes up just shortly after birth. So as babies are born, they may have a slight heart murmur. Or at least it sounds a little bit like that, because blood might be flowing back and forth between the right and the left atria shortly after birth. The pectinate muscles, these are muscles on the surface of the right atrium, and they cross over to the anterior wall. And then we have the auricles. The auricles are what we're going to call the appendages of the atria. When they're not filled with blood, they just look like loose flaps of tissue. They look like elephant ears, if you ask me, which is kind of why I think it's called an auricle. And so, yeah, it reminded anatomists of an ear. So when you look over here at this slide, here is the auricle. So here would be the right auricle. You can't see the left auricle because of the orientation of this particular picture. Here's the fossa ovalis again, the pectinate muscles right here. And then when we start looking down here, this is a valve. This is the right atrioventricular valve, or AV valve. It's also called the tricuspid valve because it has 3 different mountings into the ventricle. And the tricuspid valve separates the right atrium from the right ventricle, and it controls backflow. So when you see the ventricle contracting, this valve snaps shut so that blood travels up here to the pulmonary arteries rather than flowing back into the atrium. The ventricles themselves have their own septum. It's called the intraventricular septum, and it's a real strong muscular layer. The trabeculae carneae, looks like carne, right, is a set of irregular muscle that folds inside into the ventricles. So here are some areas here. Remember the trabeculae that we saw in bone? It's the same structure. It's just made out of muscle instead of bone. Papillary muscles are really interesting muscles that project into the inner surface of the ventricle, and it's attached to the chordae tendineae. The chordae tendineae, which are these things right here, okay, here's another example of chordae tendineae, are these pieces of connective tissue that attach the valves, the cusps of the valves, to the actual papillary muscle itself. So chordae tendineae are basically like the tendons of the heart, holding connective tissue onto cardiac muscle. And so then the last thing is that the myocardial thickness itself does differ between the right and the left side of the heart. Sorry, wrong way. Here's the left. Here is the right. The reason why the left ventricle is significantly thicker than the right is because the left ventricle has to generate significant or sufficient blood pressure to push blood up through the aortic arch, up through the carotid, up through the brachiocephalic, up to your head basically. The left ventricle has to generate enough blood pressure to overcome gravity. In addition, it has to generate enough blood pressure to send blood out to the entire body. And so it turns out that our blood pressure changes over the course of the circulation in our body, which we'll talk about later. I will stop here and move on to another lecture. Let's first just talk about veins. Veins are always returning blood to the heart. Arteries always move blood away from the heart. Artery A, blood away from the heart. The right atrium's blood vessels are going to be the superior and inferior vena cava. We saw that. And the coronary sinus. The coronary sinus is going to be sending blood or receiving blood from the heart. Okay, that's really important. From heart. The right ventricle branches out to the pulmonary trunk, the right and left pulmonary arteries, the left atrium, the pulmonary veins, and the left ventricle, the ascending aorta. All right, I'll be back in just a couple minutes for part 2.